Hello everyone, this is chapter 7 problems. We are going to solve some of these questions that I posted on chapter 7 problems. So let's get started. I am not going to work on these essay type questions. Okay, so these already have detailed solutions. All right, and knowledge questions 1, 2, 3, 4. Okay, essay, all the answers are here, so you please go over these questions, but I'm going to go over some of the, so there are 6 essay type solution type questions. I'm going to go over the multiple choice questions. Let's start from number 2. Number 1 is relatively easier. Okay, so number 2 starts like Q hat quantity, this is the estimated demand for a good, Q hat 25 minus 5p, so this is the own price of the good, plus 0.32 m plus 12 pr. Okay, where Q is the quantity of demanded of the good. Okay, so whatever we are selling, this could be cookies, I'm totally making it up. All right, P is the price of the good, so P is the price of cookies. M is the income, so this could be median income in the area, and PR is the price of related good. We don't know what kind of related good it is, so it could be substitute, and complement. We talked about this in my class notes and videos. Okay, if income decreases by 1,000, so M, change in M, right? Income decreases by negative 1,000, so it says basically plug in negative 1,000 in this equation. All else constant, quantity demanded. So what will happen to Q hat if income goes down by $1,000? So first of all, what you have to do, we're holding everything else constant, just focus on this. If it's only looking at the impact of income, so change in quantity divided by change in your income by 1 unit, this is 1 unit change, right? It is 0.32, so that's the coefficient estimate, 0.32. Okay, so this is if 1 unit of income change. So what you can do alternatively, plug in this negative 1,000 here, 0.32 times negative 1,000, so it is negative 320 units. So if income M goes up, if income goes down by 1,000 units, $1,000, right? Quantity, its impact on quantity will be negative 320. The quantity will go down by 320, so it's going to decrease by 320 units. A is the correct answer. So you're basically grabbing the coefficient estimate times whatever the change that we are looking for, because this 0.32, this coefficient estimate, gives you what happens to the quantity demanded if income goes up by 1 unit. It's going to go up by 0.32 units. Okay, so income goes down by 1,000 units, multiply it with that coefficient estimate, you're going to find the answer. Question number 3, same thing, same question set up. It's asking us the good is, okay, inferior, normal, normal, inferior. This is again information about inferior to normal. So it comes from the impact of income on output. So if quantity demanded goes up when income goes up, this is a normal good. We talked about this. Okay, so if your income goes up, you're going to go to the movies more often instead of watching Netflix. So if quantity goes down when income goes up, okay, so your income has gone up, your quantity demanded of this good has gone down. This is what we call inferior good. So inferior goods are goods that we consume less of when our income goes up. So check this out. In our case, this says basically if income goes up, my income went up, right? My income went up by $1 here in this example. Quantity demanded went down by 0.65 units. So this is an example of an inferior good. So inferior. Why? Coefficient on PR is negative. No, PR is a related good. Inferior C, normal C depends on how people react to a change in their income. Okay, inferior good since the coefficient on M is negative. Correct answer is D. Let's move on to question 4. Again, the same setup. This good, you know, whatever this good is, and good R, are they complements, substitutes, so which one? Okay, so look what's happening here. Price of a related good is going up. Coefficient estimate is negative. That means quantity demanded. This negative coefficient means they move opposite directions. So price of related good goes up. Quantity consumed of this good goes down. Example is, for instance, gasoline. Gasoline price goes up. Demand for trucks will go down. So what kind of goods are these? These are what we call complements. Complements, they go together, right? Complements, because coefficient of PR is negative. Correct answer is C. Again, right now price of gasoline has gone above $4 in all 50 states, right? So demand for energy inefficient cars will go down. Okay, number 5. All right, so in this question, for linear demand function, I'm going to write this down again. A plus BP plus CM plus DPR. Income elasticity. Income elasticity is percent change in quantity as a response to percent change in income. What is the percent change in quantity? So this is change in quantity, you know, final initial divided by initial quantity divided by what's the change in income. Percent change in income divided by initial income level. We're going to bring this up to the numerator, delta Q divided by Q. You bring this up to numerator by flipping it or finding its inverse according to math. So rearranging delta Q over delta M, M over Q, delta Q over delta M is nothing but C here. Okay, kind of covered it. So this is C here. Change in quantity as a response to 1 unit change in delta Q over delta M is the, change in quantity as a 1 unit change in M. So you're going to see, what are you going to see? Not 1%, but 1 unit. So it's going to be C, this delta Q over delta M is the C n times M over Q. So if you forget the formula, you can easily derive it. All right, question number 6. All right, so nonlinear demand function. So we do natural logarithm transformation plus C, this is C ln M plus D ln PR, okay? So in this case, cross price elasticity of demand. Cross price elasticity of demand is percent change in quantity of our good in question divided by percent change in price of related good. The great news is that once you do this transformation, right, percent change in quantity will be change in ln Q divided by change in ln PR. Basically, D is going to be your cross elasticity of demand. Okay, so remember, it's very easy. In logarithm form, the coefficient here will be, this coefficient will be the elasticity. So it kind of makes it easier. Okay, question 7. Build-Right Concrete Products produces specialty cement used in construction of highways. Cool. Build-Right is a price-setting firm and estimates the demand for cement by the State Highway Department using the demand function in the nonlinear form. Cool. So Q is the yards of cement demanded monthly. P is the price of build right cement per yard. M is the state tax revenues per capita. Okay, so this is like how much state gets per capita. PR, this is R, the price of asphalt per year. So asphalt and cement are related. Okay, so what you do in this case is you do natural logarithm transformation. Ln Q equals ln A plus B ln P plus C ln M plus D logarithm natural logarithm PR. So once you do this regression, right, the dependent variable is ln Q, intercept ln A. This is going to be the coefficient of this guy, C hat, D hat. Okay, so let's continue. Given the above, the estimated demand for cement is, so demand for cement is going to be, so percent change in quantity divided by percent change in own price, elasticity. Oops. Okay, it kind of froze on us. Elasticity, price elasticity of demand. So the good news is that this beta head will directly give that number, negative 0.8. So this is less than 1 in absolute value. So it's inelastic. Okay, inelastic because elasticity is negative 0.8. Next question. I was going to skip question 8, but let's do it. Seasonal or cyclical variation in time series model is regular in nature, yes, and can be accounted by for dummy variables, yes. So this is correct, but I like to keep reading. It can decrease the accuracy of the forecast if not accounted for by dummy variables. True. You need to account for seasonal variations. Exhibits irregular variation that can be accounted by dummy variables. I mean, calling it irregular is not really technical. It's not right. So this is wrong. So A and B, D is the correct answer. Let's do number 9. Okay, so this is a model with dummy variables, right? The consulting firm estimates the following quarterly sales forecasting model, QT, A plus BT plus CD. The equation is estimated using quarterly data from 2001. So this is supposed to be, 2001, 01, first quarter, or is it 2010? Yes, it's supposed to be 2010. There's an extra 0. All right. It doesn't matter for now. In 2020, third quarter, T from 1 to 43. So this T is a quarterly variable, trend variable. The variable D is a dummy variable for the second quarter. Okay. So you can write this model like this for second quarter. Okay. You write it down as QT equals A plus BT plus, right, for second quarter, this D takes on a value 1. So it's going to be plus C. Okay. So for second quarter, QT, second quarter, for second quarter, it's going to look like QT equals A plus C, right, plus BT. For first, third, and fourth quarters, your model looks like this. QT equals A plus BT. That's it. Why? Because this D takes on a value 0 for other quarters, therefore it vanishes. Perfect. So this is the estimated model. Given the above, at 1% level of significance, is there a statistically significant trend in sales? So let's take a look. Okay. So intercept is A, head is 22.5. Okay. T, this is the time trend for each quarter. This is B head. And D is the coefficient. This is C head. which is the coefficient estimate of the dummy variable for the second quarter. Okay, is there a time trend? So we're going to see if there is a statistically significant trend in sales. We focus on this T. Okay, when I see T, this is that one. Okay, there's some inconsistencies in terms of naming. It doesn't matter, it's that one. So if this is statistically significant at 1% level, then yes. Let's see. So p-value is 0.0016, which is less than 0.01. So yes, it is statistically significant at 1% level. Yes, because this is less than 1%. A is the correct answer. Let's continue. Same setup, question 10. Let's see what it's asking us. Given the above, these estimates indicate that second quarter change in sales is. Okay, so this dummy variable, okay, this dummy variable accounts for the impact of the second quarter in each year, okay? So it says clearly, is it statistically significant? Yes. Okay. So what is going on here? So second quarter, for some reason, so in the second quarter, this company is doing good. January, February, March, first quarter. April, May, June. So they're doing really good in April, May, June quarter. So what's the impact? So 2 units higher in terms of their sales. Okay. So 2 units higher in the second quarter than compared to what? All the other 3 quarters, first, third, and fourth quarter. Okay, that's it. So the answer is C here. Let's move on to question 11. Consulting firm, same setup. Given above, what's the estimated intercept of the trend line in the second quarter? Okay, so this is a little different, right? Intercept of the trend line. So let's write down this model, right? D takes on a value 1 for second quarter. For second quarter, okay, your model becomes QT equals, we wrote it down, but I'm gonna write it down, BT. This C, D takes on a value 1, so plus C. So your intercept, A plus C, will become your intercept. So where is your A plus C? This is A hat, B hat, C hat. So I'm going to add A plus C. 24.5 is the intercept of the trend line. 24.5 right here. Question 12, the same question. All right. So what is it asking now? Using the estimated trend line above, what's the predicted levels of sales in the 2020 fourth quarter? I really like this question. This is a little bit different. Cool. So 2020 fourth quarter. So here they call 2020 third quarter as unit 43. Okay. So they named this, they plugged in place of T, right, or capital T. Actually, they did it capital T here. I don't know why the difference, but this is T, same thing. Okay, so it's basically saying for the third quarter of 2020, that's the 43rd observation. Therefore, the fourth quarter of 2020 is 44th observation. So what am I going to do? I'm going to write down this equation for any fourth quarter first. Okay, so any for fourth quarter, this equation becomes QT plus, QT, not plus, QT equals, my brain is going next step, A plus BT, okay? So for the fourth quarter, D takes on a value 0. Therefore, this thing vanishes. Okay, that's it. So this is my equation. Okay, so let's plug in the numbers from the table. A hat is here. B hat is here. I don't need C hat. So it's going to be QT equals, plug in A hat. So hat, right? 22.5 plus 1.86 times t or small t, big T, doesn't matter. They kind of interchange the notation, which is kind of weird. So because we're talking about the 2020 fourth quarter, you need to plug in 44 when you see t here. So let's pull up our calculator. Okay, so 44 times, right, 1.86. So this is 81.84. 81.84. We're gonna add 22.5 on top of it, plus 22.5, which is 104.34. 104.34. So what did I do? I have these coefficient estimates, right? A hat, B hat. For whenever we saw t, we plugged in 44 because that's the value coming up. All right, so 104.34C is the correct answer. Let's also work on this one. This is a different question. Question 13. The manufacturer of Beanie Baby dolls use quarterly price data, right? 2012 first quarter, that was period 1, value 1. 2020 fourth quarter is 36 period. Okay, cool. And they estimated this model, PT. They're forecasting doll prices in year of 2021. Okay, the next year. Cool. PT is the price of quarterly price of dolls. D1, D2, D3 are dummy variables for first quarter, second quarter, fourth quarter. So for, third quarter. Okay, my brain is going to the fourth quarter. That's why. So for the fourth quarter, all these dummy variables take on a value 0. And D1 takes on a value 1 only for the first quarter. I'm just clarifying. Thanks. Cool, cool. To forecast price of dolls in year 21, PT is the quarterly price of dolls. D1, D2, D3 are dummy variables for quarters. These are the results. So here I have my A hat, B hat. Okay, so estimated values. This is C1 hat, C2 hat, C3 hat. Perfect. The estimated quarterly increase in the price. Interesting. So these are dummies for specific. These are dummies for specific quarters, first, second, third. But the quarterly data is this time trend that is measured quarterly. So the estimated quarterly increase in price, regardless of which specific quarter it is 0.8. And the estimated annual price increase, if you look at annual price increase, multiply it by 4 because we're talking about 4 quarters, 3.2. Okay, if it asks us about a specific quarter, then you could calculate that specific quarter.